to finish off with question E here, to finish off with question 3 here, we have A and B are in exponential form, and then you'll see down below C and D are then in the natural logarithmic form. And we want to solve for X and solve to 3 decimal places. So if I have E to the exponent of 2X equals 12, we want to bring this exponent down because that's where our X is, right? So I want to change this exponent form into logarithmic form. So to change from exponent form to logarithmic form, right, the 2X comes down, and I have that equal to, let's say, log base E of 12 from last year, or now we've just learned that if it's log base E, I would have 2 of X equaling the ln of 12. And then if I want to get X by itself, I simply divide by 2, just showing that, highlighting, to get X equal to, and then this is calculator, do the ln of 12 divided by 2, and you should get 3 decimal places, 1.242. So again, just making sure that you're typing that in properly. Or there's another way that we could do this. If I just took the natural logarithm of both sides, let's say right away, or you can choose which way you want to do it. If I had the ln of E to the exponent of 2X, sorry, this is a separate way, equaling the ln of 12, right? Ln of E cancels each other out, right? And I'm left with 2X equaling the ln of 12, divide by 2, right? You're in the same spot there. X is going to be equal to 1.242. Okay, so let's try B here. The only difference between A and B is I have a number in front of E. So I can't change this to logarithmic form the way that it is. I need to deal with this 3 that's in front of the E first. So all I'm simply going to do is just divide by 3. So I'd have 12 divided by 3 equaling 3 E to the exponent of 4X minus 3. Divide that term by 3. And so then I would have 4 equaling E to the exponent of 4X minus 3. And now this looks the same as A, right? Just except it's the left and right side have been switched. So if you wanted to rewrite it, it's up to you. You don't have to, but if you wanted to compare E on the left side and your constant on the right side, okay, so then I would have, let's say we were rewriting this then as bringing the X in front, I would have 4X minus 3 equaling the log, again, base E. You don't have to write this out. You can skip that. That step would be 4X minus 3 equaling the ln of 4. So if I want to slowly get X by itself, then I would have 4X equaling the ln of 4. Right? Just be careful here when you're adding 3. You should put brackets maybe around the ln of 4 just so you don't actually accidentally add the 4 and the 3 together. Right? This is the ln of 4, and then we're adding 3. So then I would divide by 4, just changing color just to show you that we're dividing by 4 on both sides. So again, type that into your calculator. You have the ln of 4, get the value, then add 3, and then divide 4. And then you should have 1.097. Or there's another way of writing it out, right? I have to get rid of that 3 right away no matter what, because there's a number in front of the E. So I'll just leave it this color. So if I have, again, the first step is going to be the same, 3 divided by 3E 4X minus 3. It's going to leave us with our 4 equaling E to the exponent of 4X minus 3. So then if I got the ln of both sides, so the ln of 4 equaling the ln of base E to the exponent of 4X minus 3, I'd have the ln of 4, ln and E cancel out, and I'm left with 4X minus 3 down as my base there. So then same thing, I'd have the ln of 4, but I want to bring over the negative 3 to positive 3. And then same thing there, divide by 4, everything's the same now, and I would get X equaling to 1.097. And I just left the x on the right-hand side also just to show you that as well, if you didn't switch it. Okay, so there's some that are in exponential form, and we've changed them to logarithmic form. What if they start out as natural logarithmic functions, C and D? Okay, so if I have the ln of 3x equaling 2, so again, ln is the same thing as writing it out as log base e, right? 3x equaling 2, just to kind of, let's say, get it used to how you would have seen it last math class. So when your natural log is of a value that is unknown, so I'm doing the log base c of, and I have an unknown in there, or when I'm doing the ln and the value here has an unknown in it, I need to change it to exponential form. Ln is in base e, right? Ln is log base e is the same thing. Ln is considered to be in base e. So if I were to write it out like this, then I would have, changing it into exponential form, then I would have e, the 2 is the exponent, equaling the log of e equaling 3x. E squared equaling 3x. So then what am I getting? I'm getting, solving for x, so then I'm just dividing by 3 on both sides. Right? So x is equal to, this is calculator now, e squared divided by 3. So you should get roughly 2.463 equaling x again. Or, I'm just going to go to the left here. Another way of doing this would be getting a base of e, right? Have each side be a base of e. So if I have e, and then these are my exponents, to the ln of 3x equaling e exponential form squared, then that cancels out and I just have 3x equaling e squared. And then again, I want to get x by itself, so divide by 3. X is equal to, again, whatever e squared divided by 3 is on your calculator. We end up with the last couple steps being the same, right? 2.463. Okay, last one, let's look at D. The ln of x is equaling 2, right? So again, we have a natural logarithm, and it's of a value with an unknown in it. So we need to change it to exponential form. So changing it to exponential form, let's say instead of the ln, just showing you that you could have written it out as, let's say, log base e, right? Of ln of x equaling 2. So changing it to exponential form would then be e squared from the 2 over there equaling this side ln of x. So if I want to slowly get x by itself, just showing you again this step, just making it more familiar from functions class, I've got log base e of x. So I need to change this to exponential form again, right? Because I have, again, I have an unknown that's still there, so I need to change it into exponential form. So then I have exponential form e to the exponent of e squared, right? Equaling, the log of e is gone and equaling x. Then this is on your calculator. So now you have to practice what is e to the exponent of e squared. And you should get a value of 1,618 decimal, sorry, I didn't have room here, 178. That's a 1,618 decimal. Don't forget to put 3, 178. Or, again, another way that you could write it is starting with your base of e right away. So e, right, to the exponent of ln of x is equal to e as my base with an exponent of 2. Okay, so then these cancel out and I'm left with ln of x equaling e squared. Okay, I still have my unknown, so I need to change this into exponential form again. So I have e to the exponent of ln of x equaling e to the exponent of e squared. These cancel out. So I'm left with x equaling same thing, e to the exponent of e squared, and then it's just calculator 1,618.178.